So this is a brief overview of the information that we dealt with in class today. This is 8/31/2020. So we began by talking about taking actually what is chemistry, and I did several little demonstrations, not several, but I did a couple of demonstrations about the nature of chemistry, and I'm going to skip over that in this video and begin with the measurement section. So I'm going to go up to this little lab section here and talk to you about how to take readings in chemistry. So if you look at this burette, now burette you read from top down. See how that's 40 and that's 41 down here. So this line here is 40 and this is 40.1. So we need to estimate where we are between 40 and 40.1. So we're not all the way down to 40.1. We're not even quite halfway down. So it's like 40 milliliters and 0/10, but about 3/100. So if you divide this space into tenths, it's called a hundredth because it's a tenth of a tenth. So we would call this number 40.03. If we look at this one, here's 24, there's 24.1. See, 25 doesn't come until down here. So we would say that that's 24.17 maybe, 24.17. I'm dividing this into 10 spaces, and I think I'm more than halfway between this line here and this line here. So 24.17 would be okay. But if you said 24.18, that would be correct also because that last digit is a guess. I'm going to skip over this one, but if I look at this graduated cylinder, this is 50. There's 60 up here. So these are in 1 milliliter increments. So here we're dividing the space between the lines into 10 parts, but the 10 parts are tenths. Each one is a tenth of a milliliter instead of a hundredth like the burette was a minute ago. So this is 50, 51, 52, but not quite 53. So I'd say it's about 52.8 or 52.9, but you can estimate that last digit, and both 52.8, 52.9 would both be right. Down here, I'd say this one's about halfway between these two marks. That's 35, that's 40, so I'd say that is 36, that's 36 here, that's 37. So 36.5 is about what it is. Maybe 0.4, if you wanted to call it that, would be all right. Down here on this beaker, we know only we're marked in the tens place is all we know for sure, because that's 40, that's 50, that's 60. So we could say, well, that's not quite to 50, but it's beyond 40, so I'm going to break this space into 10. In this case, the 10 divisions are in the ones place. So that would be about 48, is what I'd call that, 48 milliliters. And that's a guess. The last digit is a guess. So in science, when we measure things, we want to know how much we have and also how well we know how much we have. And that concept's called significant figures or significant digits. So here's some rules about them. They must represent a measurement and they include an estimated digit, and that will be the last digit that is estimated. And we need to know that any digit that's not a zero is significant. So that brings us to the zero rules, and zero is a little confusing because sometimes zeros are placeholders and sometimes zeros tell us exactly that we know that there is nothing there. We've measured it. So here are the rules about zeros. Zeros in front are never significant. So zeros in between two other non-zero digits are always significant. And a zero at the end is significant if there is a decimal point anywhere in the number. All right, so those are our zero rules. And we did some examples in class, and I'll run through. So like looking at this one and analyzing it, as this zero here was a zero in front, so according to that rule, it's not significant, and the same thing is true for that, because both of these numbers are in front of non-zero digits, so those are both not significant. This 5 is a non-zero, and all non-zero digits are significant. This 0 is between two other numbers, so that makes it significant. This 3 is a non-zero digit, so that makes it significant. And this 0 is at the end, but there is a decimal right here, so it's as significant if there's a decimal point, so yes. So in this case, there were 4 significant digits. All right, in this number, that's a 0 in front, not significant based on that, and this number is significant because it's a non-zero. And I have a little note here about tenths. This is the tenths place, so that measures tenths of a meter, which is about this long. If you were going to measure something like this pencil cap, which is only this long, that's not even a tenth of a meter long. So you can't measure tenths when there are no tenths, because it's not big enough to be a tenth. So therefore, if you can't measure it, it's not significant, because a significant figure must represent a measurement. That is why zeros in front are not significant. All right, so for homework, applying those rules, I want you to do this assignment. So down at the bottom of the page here, this is the homework page from my website. So you're going to go to this link and try it. So I'll do a couple with you. Let's do a couple harder ones. So we'll do this one. This is 1, 2 significant digits. These zeros are not significant because there is no decimal. Zeros at the end are significant if there's a decimal, and there is no decimal, so there'd only be 2. So you put in 2, and you check your work, and you find out you got it right. So this little activity will give you immediate feedback. So one more thing. For numbers like this, you don't need to worry about the scientific notation. The exponential part, does not count. Only this part counts. So that'll have 3 sig figs. That'll have 3 sig figs. This number would have, all 5 of those are significant. You just look at this part of the number. So you only consider what's not times 10 to the whatever. Times 10 to the whatever does not count on scientific notation questions. All right, so I need you to practice those and get good by Wednesday. And that is the end of this little recording. You figure out how to shut it off, save it, and I'll post it.